Hello, today we're going to talk about 5-5, which is direct variation. We have two vocab words today. Direct variation is a special type of linear relationship that can be written in the form y equals kx. And then we have constant variation, and that is the constant k that you see in the equation that I just mentioned above. So y equals kx represents direct variation, and k, the number that's in front of x, is what we call the constant of variation. So we're going to be doing a couple things with this. The first thing is just identifying if an equation represents a direct variation or not. So in order to do this, we ask the question, can it be written in the form y equals kx? So essentially what we want to do is solve the equations for y, and then if they are in that form, they are a direct variation, and if they are not in that form, they are not a direct variation. So here I want to solve for y. Y is being added by 3x, so I'm going to subtract 3x from both sides. So then I get y equals negative 3x plus 8. Now notice that this is not in the form y equals kx. Okay, we got the negative 3x part, but then we have this additional plus 8. So this is not a direct variation equation. Let's look at another one. So once again I want to solve for y. So y is being times by 3 and added by negative 4x. So negative 4x, to cancel that out, I'm going to add 4x. So then I get 3y equals 4x. And then I'm going to divide by 3. So y equals 4/3 x. So this is written in the form y equals kx. So it is a direct variation. And when it is, it will usually ask you to identify what k is. K is always the number in front of x. So here, k is 4/3. Okay? So that's how we identify direct variation from an equation. Now the next thing is, how do we identify them from ordered pairs? Now, in order to figure this out, we ask the question, what happens if we solve y equals kx for k? Well, in order to do that, I would need to divide by x. And when I do that, I see that k is equal to the ratio of y over x. So what I can do, using that information, the ratio y over x is equal to k, like we just proved up top. So in order to see if something is a direct variation or not, we can check the y to x ratio. If the y to x ratio is the same everywhere for each ordered pair, then it is a direct variation. So here's what that looks like. If I'm given a table and it says tell whether it's a direct variation, what I'm going to do is find the y to x ratio for every pair. So here I'd have 6 over 2, which is 3, 12 over 4, which is 3, and 18 over 6, which is 3. So yes, it is a direct variation. Y over x is the same for all ordered pairs. That's how I would explain my answer. Okay, so that's how I figure out from a table if it's a direct variation. And then the next thing we want to do is write and solve direct variation equations. And here's what these problems look like. And they actually look a little more complicated than they actually are. So this says the value of y varies directly with x. When y is 3, x is 9. Or y is 3 when x is 9. Same thing. Find y when x is 21. So what we're going to do is we're going to set up a little proportion here. We know that if this is direct variation, as they tell us it is, then our y to x ratios will always be the same. So I'm going to create a y to x ratio over here, which 3 and 9, it tells me that y is 3 when x is 9, and a y to x ratio over here. Except for over here on the right side, I don't know what y is. I just know that x is 21. So then we go back to, let's see, I think we did this in chapter 2, where we cross multiply and solve. So I get 9y equals 63. So then I'm going to divide by 9. And I figure out that y is 7 when x is 21. And that's how I'd solve that particular direct variation problem. Let's look at another one of those just to make sure we know what we're doing. So again, they tell us that y varies directly with x. So I know that my y to x ratios have to be the same. Y equals 4.5 when x is 0.5. Find y when x is 10. So this is how, again, I'd set up my proportion, and then I'm going to cross multiply. So get 0.5y equals 45. And I'm going to divide by 0.5. I'm going to figure out that y is 90. And then last but not least are story problems. A group of people are tubing down the river at an average speed of 2 miles per hour. Write a direct variation equation that gives the number of miles, y, that the people will float in x hours. Then graph. So the first thing we got to do is write an equation. And we know right away it's going to be in this form because it says it's a direct variation equation. So, y is the number of miles they're going to travel. X is hours. So how would we calculate the amount of miles they would travel if we know how many hours they traveled? Well, if I know they're going 2 miles per hour and they travel, for example, 4 hours, that would be 8 miles. That means I do 2 times the amount of hours they travel. So there's my direct variation equation. Then I'm going to choose some values of x and generate ordered pairs. Okay, we'll just keep it simple here with 1, 2, 3. So then I have 2 times 1, which is 2. 2 times 2 is 4. And 2 times 3 is 6. So then I have 1, 2 as an ordered pair. 2, 4, 3, 6. And then I'm going to go ahead and I'm going to graph the points. Now, of course, I'm going to label my axes because it's a story problem and I have to. So this is miles. 1, 2, 3, 4. So I got 1 hour, 2 miles, 2 hours, 4 miles, 3 hours, 6 miles, and then I'm going to go ahead and connect. So there, I've written a direct variation equation, I've come up with some values, and then I've graphed it. So that's how I complete the story problems. And that's it for 5-5. We'll see you tomorrow.